Welcome to this lesson, friends. In this one, finding limits graphically and numerically for a function with an asymptote. I'm going to make up such a function. I'm going to type here f of x is equal to, for example, 1 over, and then you can say x minus 2. And take a look at what happens if I try to evaluate this at x equals positive 2. So it would be f of 2 is equal then to 1 over, and then 2 minus 2, you square this, and then from here this would be 1 over 0 squared, which then would be 1 over 0. And often, this is called undefined. There's no value assigned to 1 over 0, in other words. So the next step in the process is the following. Imagine I want to find an answer to this question. The limit as x approaches here, for example, positive 2 of this 1 over x minus 2 and this quantity is squared. So I want to know, what does this limit equal? Well, one thing that you can do is just graph it using a utility. Whatever your utility happens to be, a TI-84 calculator, some kind of software online, Desmos. Here I'm going to type the following, 1 over, and then I'm going to say here x minus 2 quantity squared. And when I graph it, it looks like the following. You can tell, you see, look at this very carefully. As x approaches 2 from the right side, the values of the function blow up towards positive infinity. As x approaches 2 from the left side, the values of the function also blow up towards positive infinity. Sometimes it helps if you scrunch this down a little bit, you see, and then you see this volcano shape even more. Now, right, so then, here, on either end, it's really infinity in this position, but it's also infinity in this position. So we might answer this question, lastly, by saying that it's really infinity. You have to be really careful. See, infinity is not a number. It's a concept. So while we might write infinity, and a lot of people will, this is shorthand for the following, DNE, which stands for does not exist. That's a proper way, that's the proper way to think about it. The other way to think about this is as follows. Do some calculations, so take a look. Imagine, in other words, you want to study to see what the limit is around x equals positive 2. You want to grab a value slightly to the right of positive 2. So you might do f of 2.1 first. That would be 1 over. And now you'd have here 2.1 minus 2. You square this quantity. If you want, you can punch this into your calculator, and you see it gives you a value of 100 as the output. So this is equal to 100. Now it's hard to see a pattern from only one value, obviously. So do it one more time. Grab a value close to 2, but just a little bit to the right of 2, like 2.01. That's 1/100th to the right of 2. That's okay. It's very close. So 1 over 2.01 minus 2. Square this quantity. Calculate this quantity. So here you see it comes out to be 10,000. Now I think that perhaps the pattern is a bit more suggestive of what's happening, which is that the closer we get to x equals 2, right, the bigger the values of the function. They're blowing up towards positive infinity because you see it's 100 and then it's suddenly 10,000, way bigger. You want to do something similar on the other side of 2. So take a value close to 2 but slightly to the left. So for example, 1.9. That's a value to the left of 2, but very close. And plug it into the function. So it's 1 over 1.9 and then minus 2, square this value here. Punch this into your calculator, for example, and this gives a nice value of 100 also. Do it one more time. So f of 1.99, that's very close to 2, but to the left still. And then 1.99 minus 2, square this quantity. And then let's see what we get here as a result. We get 10,000. So those outputs are the same. In other words, what it's telling you is that as you approach x equals 2 from the left side, the values of the function also blow up towards positive infinity this way. This is numerical evidence that basically supports the conclusion that I mentioned first by saying that the limit as x approaches positive 2 of 1 over x minus 2, that quantity squared, is infinity, which please remember is kind of shorthand for does not exist, in other words. And that is it for this one, so thank you. I'll see you in the next video.